Okay, hi everybody. This is our first run through of an agent solving a simstack challenge. So a simstack challenge is a kind of long horizon task, similar to like a complex development task. It's not just about code generation. It's also about being able to debug things, being able to lock things down, being able to follow problems to their source and trace them down. So what we're trying to do is we're trying to test different AI agents, and the tool that I'm using to do that is called Warp. And what I'm going to do is I'm going to first of all restart the simstack challenge. So this is going to build it from scratch. And this will take a little bit of time because it's got to boot up a user server, which is the thing that the agent will play in. It will have a full access to the box, root access to the VM, so it can do whatever it wants in there. A traffic generator that's spitting real-life, real-time traffic over the wire, so that's putting that box under heavy load, and a network for them to communicate under. And then, as you'll see when we get to the challenge, the agent has to go in and fix various things that are broken within the user server, such as code, missing indices, all sorts of things like that, in order to get a chart working. And this kind of long horizon task usually takes senior engineers between half an hour and an hour to do. So it'll be interesting to see how quickly the different models can solve it. We're going to start by looking at Claude 4 Sonnet. That's just the one that happened to be connected in my terminal, so we'll start with that one. But we'll also be able to test out a few different ones as well. What'll be interesting is that the agent may or may not use a kind of planning mode, so it might be a combination of different results. And we're planning to report all of this onto a leaderboard. You see, I'm going to use this timer here to watch it do it. Occasionally, I might need to help it. I probably won't try and prompt it very much, but what I will do is if it gets stuck, for example, reading from a file, fails to quit, to exit, and that sort of thing, I'll tap Q, I'll tap Enter, I'll tap Control C if it's inspecting processes, because it sort of struggles usually to read those as part of a background process. So I'm going to skip the video now to when this is done, and we will start the challenge. Cool. So as you can see, now it's started up the servers, and the first thing that will happen is a CEO email will come in. Now I'm going to copy paste a couple of these things across into the agent when it starts the challenge so that it gets an opportunity to actually see how to do this. But there's a chart with a bunch of rides going on, and I'm going to have to report to the agent how the chart is doing so it can ask me. You'll see this chart is polling an endpoint all the time. It's an active endpoint, and it's expecting to get back some kind of number. What we're going to do is we're going to try and see if we can get this chart working. And then there's another challenge with another chart. So the way I'm going to do that is I'm going to SSH in on here, but I'm not going to SSH in the SAM account. I'm actually going to SSH in using my root key into this IP address. 107.203.73, and I think there's nothing hidden behind there. Is that right? Yeah, that's great. And that's fine. And you'll see that we are in the root user account, and we've got a bunch of things happening in here. We can ls, for example, to take a little look, and you'll see that we're in the home account with a few different bits and pieces. I'm going to put them in the user account, which would be where they would normally go, so that they can get into the correct account for that. And I think it's going to be called Sam. I think this user. Great. So now they're in the SAM account. You can see there's a notes.txt, which was mentioned in the CEO email. And I'm going to just start them from here. I'm going to reread the CEO email. Let's copy paste all of this. And give them some parameters on this. So we want to go into agent mode. I'm going to say, you are inside a server. You are trying to get a chart working that reads active rides. It expects, and I'm going to say what it expects to receive JSON like, and then we can copy the exact chart info, which I think is that active rides number. Active rides number from the endpoint HTTPS user -1072.simstack.io/active. You have received. I will, since you cannot see the chart, I will report what it is saying. Right now, it says 0. Here are the CEO instructions to get going. And here are the given steps. Okay, I'm just going to hit enter and play at the same time, and hopefully let's see how this thing does. Let's hit go and start the stopwatch. Cool. So it is on the server. Yeah, great. And it's going to have a little look. It's going to have a look at the notes folder, which is what was recommended from the CEO. That's a good start. You'll see in the notes that there are a bunch of notes from the previous engineer who was in here. Yeah, that's absolutely okay if you want to go ahead and do that. I don't know if there's some sort of YOLO mode that I can enable to stop me from clicking through here. It might slow it down a little bit. But yeah, it seems to be reading the notes, which is a pretty good first step. It's got some context, and it's figured out that actually there's a bunch of things that are happening. The service is restarting. It's made a theory that it could be because of the systemd restart always. It's using system control to take a look for the units, the Firehose app, and it's using htop, which is a really good idea to see its resources that are running. So it's using those to check system resources. This is all pretty similar to what an engineer would do when they come into the system to try and do this. So, yep, it can see that there's a huge virtual memory allocation, and here it's trying to take a look at the system control status to see if there's anything being written. We've got a bunch of interesting things in the service file that seem to be an issue. It seems to believe that there is a service file in cat, and looks like it needs to change the system service file. It has, however, reported absolutely fine that the server is running on port 8080. I'm going to press Q just in case. I think probably we need to Control C this to make sure that it's still going. Occasionally it does get stuck a little bit like that. Cool. Okay, so it says that the port is running on port 8080, not 3000, which is where it wants to be. And it's headed quite deep into the systemd file. Now, it's asking me to do this stuff, and I don't want to do any of this now. I want you to get the chart working. No more questions. So let's see whether or not it is able to take that involve. It's got all the instructions that an engineer would have. Yeah, that's a good idea, is to check the local host active endpoint to see what comes back. It looks like it's not got back what it expects to see. Obviously, once this starts working, this is going to pop into life and show the actual number of active rides. That's great. So now it's looking inside the code, which is kind of the next sort of step that an engineer would do as well. And it's located that the get active ride is looking on the type, but it should be a delta with pickup. So it's going to go and take a look at what's in the database, which is a really good idea. It's struggling to find the way to get into the database, which is also the same sort of thing that an engineer would struggle with. It's looking in the .n for any sort of variables that will tell it how to get into the database. It's looking for a password in particular. Seems like it's had no problem doing so, and it can indeed connect. And it has located the reason why it's showing 0, which is that get active rides is looking for a type active. Now, before it makes the fix, it's going to back up the existing application, which is a really good idea, because if it makes any errors, then it can quickly restart it from the backup. And it wants to do that with the most recent event has a user ID combination is pickup, which is a good shout. So that's going to do a little bit of code gen, and it's trying to, interesting, yeah, okay, so it's really doing a complex query here. That's absolutely fine with me, and I've got no issue with that. I like the look of this. Let's run it. And now it's restarting the Firehose service. The question is this going to absolutely blow up the memory? Because that looked like quite a complex query that it was asking. It has restarted the Firehose service correctly, so we're at 3 minutes 47, and it's managed to get the active rides working again. This is significantly better than Claude 3.7, which usually took about 20 to 25 minutes to find this. It's double checking to make sure that the active endpoint is correct, and this active rides will gradually continue upwards at this point. And there are indeed. The CEO mentioned 12K rides, so this seems pretty good. Now, it's moving on to the next part, which is to try and keep that latency under 1 second. Now, at the moment, there aren't too many active rides in the database, so it shouldn't be too much of an issue. But as you can see, the real quality is higher than a second, and it is increasing over time as the number of items in the database is there. What it's suggested doing is adding an index directly into the database in order to solve that. I'm going to test the performance again and see whether or not we can see here as well that the average latency on our end is sitting a little bit more like 1131. That's because we've got network latency as we do the requests across the internet. I'm going to say that that's not good enough to get an internal latency of 0.83 seconds. We want that way lower. We need that to be consistently this average latency lower than that. Although that said, the index does seem to have kicked in across these bars here, 604, 826. So actually, we are now within parameters, I think. So now that we've fixed that active endpoint, we've got the chart latency under a second, I think that we are good. Yeah, we're absolutely good. That's great. So the average latency does seem to be shooting up occasionally. It's pretty variable. Here we've got one coming in at 2,140. So I'm going to say the average latency on my end looks like it spikes sometimes up to 2,000 milliseconds or higher. Let's get it more consistently down. So again, this is a kind of the engineering challenge here is to make sure the average latency is consistently under a second. So let's see whether or not it can do that. More than an index is required to make this happen, especially with a more complex SQL query like the one that it's running. So what's it going to do here? It's going to try and create an active writes counter. Okay, so it's going to split that out to a different table. A simple counter with periodic updates. Question then is about periodic updates, like how long is it okay for it to be out of drift? And then how will this scale as a large number of items end up in the database? If we've got millions of active rides, is that going to be a bit more of an issue? So there we go. We're pulling a bunch of things from the counter table, perhaps on the active rides. We've massively ballooned the complexity of this function, which is a kind of traditional thing for LLMs to do. But if it gets it working within the established parameters, then that's okay for us. Well, the average rides has now dropped to 0, which doesn't seem quite right. That may change over time if there's some sort of counter function that's on there. But what I'm noticing is that the latency is still rather high, so it's doing something. It has indeed found that its own internal testing latency is pretty good. It's just above a second. That's not too bad. But the number of active rides has now dropped to 0. So it's trying to run a different kind of test because it's not noticed that the active rides have dropped to 0. At this point, again, we're sort of seeing one of those challenges with LLMs. Great out the gate, and then struggling later. So it says the cache is working as intended, which is fantastic. However, the cache is not returning the correct number of active rides. Yes, there we go. It's noticed that it's at 0. So it needs to check to see the counter update is running in the background, but that won't be the case because this has been at 0 for a while. Then take a little look in the logs. Does indeed seem like the counter update is probably failing. Let's see whether or not that causes anything to jump. Yep, there's no problem with that command. Go for it. Just not accept any code you give me. We see a spike as the code's written. That makes sense. And the query is still turning 0. Interestingly, it seems to have opted for a 24-hour filter. So I'm going to have to tell it this chart needs to be as close to real time as possible. It's also trying to filter for active rides within a window relative to the current date, and the data on this data is set at a different date, so it will need to be a little bit cleverer because it's historic data that we're replaying. So this will be it, trying to change the filter, the date that's on there. It's going to get upset because at a certain point it's going to come back and say it's done, but I'm going to say, well, we need this to be real time. This counter approach is not a great solution. This is meant to be a real time chart. And we did mention that it's a real-time chart, and the CEO email mentions that it's a real-time chart as well. So it forgetting that it has to do it real-time and proposing a cached alternative is not going to solve the problem. Oh no, okay, all right. Does look like it updates semi-regularly. I have to go check the code to see what's going on there. That latency has come way down due to that implementation of that cache. It does look like the active rides are indeed growing in a way that you'd expect them to do. It's going to do 50 concurrent requests on the server. Great, and it's got a really, really low latency on there as well. It wants to validate that. And you know what? I'm going to accept that answer. That's a nice implementation of the cache. I thought it was holding the cache for 24 hours, but it's using a 2-second in-memory cache, which is actually great because we're only requesting this every 5 seconds, which again is mentioned in the CO email, so 2 seconds is well within that. Great, so we've got this really nice real-time system now, although the average latency seems to be spiking again. That probably is a result of the agent pumping out information. Let's go into the second challenge. So we'll say first challenge is about 1028. Pretty good stuff. We're going to go into the last hour challenge. So in this last hour challenge, we've got 2 charts that are need to be working right now. We've got the active rides chart, which as you'll see is working from before. And now we've got this rides in the last hour by city chart as well. I'm going to say you have a new challenge from the CEO. Let's add in the new CEO email. And then let's add some more context. Here's the context of the real-time chart. I can't see the place from that. It polls HTTPS. User 1072 simstack.io /last hour every 5,000 milliseconds. It expects rides by city key string and value, which is a number. And I'll give it the steps as well. Your steps. Do not ask me for help. Just solve it. Okay. So that's given the whole thing in there. For future tests, I'll make sure that the timing takes account of the fact that we've done that too. But we're starting it from about 12 minutes 20 in this particular challenge. So it wants to understand things in the historical data challenge, which is and it's looking at the date range, which makes sense. And it's correctly identified that data is indeed from March 1st, so the last hour needs to be simulated from that time frame. Again, a great assumption to make. This has caught people up in real life. We've seen they have to ask, what date is it today on the server? What are we working with? So they really seem to have solved that nicely. So it's going to go ahead and just put the last hour endpoint in with caching directly. It's the intention. So it's actually going to attempt to one-shot this entire challenge, which is very impressive. Again, for engineers that we've worked with, this seems to take people usually around half an hour or so to do. So a huge amount of code gen in here. I'm just going to accept it for the purposes of the challenge. We'll run it. And it's going to update the main application to add that endpoint, and then just have to restart it. We'll know if it's working once we see some data coming through on here. We can see at the moment it's failed to fetch any data. Yep, go ahead. Do whatever you want. I've noticed that it's now just doing this directly in files. It's not making any backups anymore, which is not best practice. So it's restarted the service. We've got a fetch error on both charts, which is what we'd expect. It's looking to see that these are indeed started. And that's back. That's in. Okay. So we have them organized by most to least rides. which is pretty good. Did these seem like a reasonable number of rides in the last hour? They do, I would say. They do. That does seem about right. Yep. Go ahead and run that. And it wants to check the latency is under a second there. We're not too sure because we're sort of hidden here, but this does seem pretty low. Wow, that's fantastic. So Claude really has just one-shotted that with that modification, building off the implementation that it had before and keeping that latency approximately the same. Very, very low indeed. Really challenging to get it that low and keep it that low. So that seems to be both challenges solved. Once it says mission accomplished, that's when we'll stop it. Both challenges solved in total under 15 minutes, which would be very impressive. Comprehensive test for both endpoints performing well under load. Very nice to validate those. Brilliant. So that's an extremely impressive solve. And at the moment, it seems to be around about half the time of we've seen engineers, Google engineers from Cloudflare attempt to solve this stuff. So very rapid in an open problem space. Fantastic. So that'll wrap it up for our Claude 4 look at solving this. Again, about 16 minutes or so, it has managed to solve both parts of the challenge. Drop a comment below if you want to join the discussion about it. Otherwise, go check out simstack, see how you can do yourself against this. We have many other challenges of this kind of thing. And we'll be running a competition in September to see who can beat the AI. Speed-wise and time-wise across a wide range of different challenges, front-end, back-end. We'll be doing some DevOps stuff. We'll be doing a bunch of security things and more of this kind of SRE escape room type stuff too. Cool. I've been Sam. Thanks very much for joining.